Hi everyone, we are Valerio, Benedetto and Luís Filipe from the MIDAS team, and today in this vlog we are talking about regressions and predictions. In particular, we will be going through a simplified example to describe how regressions work and how we can use regressions to make predictions. First of all, what is a linear regression? It's a quantitative method which allows us to understand the relationship between two or more variables. So it's a numerical approach which we can use to understand how two or more variables relate to each other, interact with each other. So when we talk about variables, we can think of things like age, gender, weight. So you can try to investigate how, for example, age and weight relate to each other, how height and weight relate to each other, or how, for example, your age and the size of your shoes relate to each other. We can use regressions to predict the value of one variable, which is called dependent variable, because it depends on the value of other variables, which are called independent or explanatory variables. So, for example, by knowing my age, I can predict what my weight might be. So if I am 30, 40, 50 years old, I might predict that my weight might be 70, 80, or 90 kilograms, for example. And we use regressions to predict the value of one variable by knowing the value of another variable.
I'm going to try to explain to you what a regression is, but typically what you do is you do it graphically. It's the best way to do it. So here you have a relationship between two variables. You can see what we usually call the y variable or the dependent variable, which is the one on the vertical axis, which is the average number of publications per year in this case. And you can see on the x-axis or the horizontal axis the number of MIDAS blogs that some person has watched. So clearly you can infer that the most they watched our vlogs, the higher the chance that they get some publications. So you can expect that there's an increasing relation, right? This is totally real, by the way. Of course, we didn't invent this data. So you can see here that you have a person that has 6 publications on average per year, and that person watches 11 of our vlogs. Then you can choose another point here, for instance, where you have a person that watches 8 of our vlogs but only has 2 publications. Every point is a person in here, and you have this relation between the number of vlogs watched and the number of average publications per year. Now, the idea is we want to understand what is the average relation between the number of vlogs viewed and the average number of publications per year. So we are going to try to draw a line that kind of reflects that average relation. And by drawing a line, we get this. Now, what is this line? It's a little bit more complicated than you might think, but not that much. It is a line that basically does this sophisticated average, minimizes the overall distance from every point to the line. But for now, you just need to understand that it is like an average line. So this is the relation between the number of MIDAS vlogs watched and the average numbers of publications per year, which you can see that it is increasing. What does that mean? That the more vlogs you watch, our vlogs, of course, the more you are going to publish on average per year. So, of course, the conclusion is that you should watch more and more of our vlog. Now, this is basically the same thing. This is that slope. It may not seem like it, but it is. Because if you remember, any line can be written mathematically if you have a slope and an intercept. So this here is the slope or the gradient of the line of the previous graph. So it gives you the inclination of the line. And the number below, it's the constant. It means the interception with the graph. You can see that, for instance, the constant in there is 1. If you For instance, if you continue this line, you will get to 1, which is basically the point where the line is going to intercept the y-axis. Okay, so we are interested in the slope. What does this slope mean? This is 0.46, more or less, this number. It means that if you watch one more vlog, you are going to get on average more 0.46 publications per year. Probably can already see, and Valerio is going to tell you a little bit more about it, that if you know that if you watch one more vlog, you get on average more 0.46 publications per year, then you can tell how many more publications you are going to have if you watch 2 more vlogs or 3 more vlogs. So go ahead, Valerio.
Thanks, Luís. So here we kind of bring together what Luís was just saying by describing the regression table. So we present the regression equation here. I know we got a formula, mathematical notation here, but we will try to explain this equation step by step so we don't get too frightened by all this. So first of all, we got number of publication, which is our dependent variable, which is equal to 1.08, which is that intercept that Luís was mentioning before in the regression table. 1.08 is the number of publications we will publish anyway, even if we watched 0 vlogs during the year. So that's just slightly above 1 publication per year. Then you got plus 0.46 times vlogs watched. That's the extra number of publications we will publish after watching X number of vlogs every year. In a nutshell, this means that for every vlog I watch, I published 0.46 more publication per year. This is the extra number of publication I will publish per year. Now, let's try to have an example and let's try to add a number now into the equation. In particular, how many publications per year would have someone who watched 8 of our videos? So we need to replace vlogs watched with 8. So we got the same equation as before. Number of publication equal to 1.08 plus 0.46 times 8. Okay, so we got the number of vlogs watched here now. 0.46 times 8 is 3.68. So that's the extra number of publications we will publish after watching 8 vlogs per year. Now, if we add up 3.68 to 1.08, we get the total number of publications we will publish, which is 4.76. So we got 2 components going on here. The number of publications we'll publish anyway, even if we watch 0 videos, and the number of extra publications we will publish after watching 8 vlogs per year. And in total, we got 4.76.
This is a very fast video and very simple. The basic message is that regressions can be a very powerful tool, and they are used indeed to do a lot of quantitative analysis. Of course, this is very simple, but then you probably know and you have seen that regressions can have multiple explanatory variables. So we are only using one, but they can have as many as you want, given some rules. Let's say you can have as many as you want, as long as you have as many observations as you want as well. But we cannot put them in an example, or at least in a simple example, because if you have more than one, let's say you have 2 variables, you are already going to be on a 3D dimension. So if you have like one more, then you are in 4D. 4D is already not representable in a screen, and as you put more and more, it's completely impossible to represent, but you can use, and the idea is very similar to what we have. Then it just enters that they also have correlations between each other. Let's leave it for another time. Now, another important message is that regressions by themselves cannot assess causality. They can only assess correlation. So in this case, in our example, obviously causal, right? So there are then other methods that you add to the regression. Regression is just a tool. Then you need to prepare your data, let's say, or use some other methodologies in the regressions that can lead you to causality. So please watch our previous vlog on causality and correlation, and we hope we are also going to create another one on how to infer causality. Let's see. Thank you. Please check this reference for basically more or less what we just taught you in this vlog, and that's it. See you on another time.
Thank you. Bye-bye.